So hope you are getting it.
Okay. So if I have to just fill up a blank in the function, so I can straight away import linked list and then get going.
Sorry, I didn't get you.
So if I have to just fix the cycle detection, I can start with importing linked list and then use all
Mhm.
its functions to build the logic.
Yeah, right.
Okay, got it. Yeah.
Yeah. So that's pretty much it. And yeah, any other doubts, any other questions, guys, you can ask. I guess no one has the doubts. Okay. Cool. I'll just share my screen and whiteboard first of all. Are you guys able to see my screen? Okay, that's great. So has anyone identified how to find if there exists like a loop in the linked list or self loop in the linked list? Did you guys identify it? Did you solve this problem?
No, but I understood the logic, like using.
Hash set, it's fine.
Yeah.
Other than that, I'm asking solutions. Hash set is fine. I was talking about like something other solution in which you don't use extra space complexity. Yeah, Floyd cycle, okay.
Ma'am, I remember you shared that fast runner and
Yeah,
slow.
right. Yeah, what?
Yeah, yeah. Like one is next dot next, and then another is next, next, next. So that approach I remember you did, but I did not do that.
When did I explain that approach to you guys?
Uh,
Did I
so
explain the slow and fast pointer approach in the class? I don't think so. I have.
midpoint, how to find the midpoint.
Oh, you okay? Using them and finding the mid. Yeah, using that you can solve this problem. But does anyone has any issue in that a solution, like how we are getting it. Using slow and fast pointer, Kishan, can you unmute and tell me like what are you actually trying to say?
uh, like at like when we run the slow and fast pointer, there will be one point
Yeah.
where slow and fast both will be meeting together.
Okay.
That
Like
at that
I didn't explain that, right? I only told you that fast moves twice as
right,
faster as
right, right.
slow, right? And like that is what I explained, if I'm right.
Yes, yes.
But
Yeah, I also remember.
No, no,
I
you didn't
didn't
explain
explain
the
the
solution.
solution to
Yeah,
this, right?
yeah, you didn't explain the solution to this.
Yeah, you
Yeah,
didn't
right.
explain.
No, that's what I was asking. Like you guys are saying slow and fast pointer, and I was like, how come the slow and fast pointer comes into picture? We have not discussed it ever. Okay, fine. We'll discuss it right now. Just give me a minute. Okay, everyone. So let's continue and see. But before that, we will discuss that the brute force to this particular problem. So, can anyone tell me that using any brute force, very simple iterative approach, via which we can find out if there exists a self loop in this particular linked list or not? Can anyone have the idea, like the brute force?
Yeah, as we traverse from 1 to 11, we'll keep on comparing the hash code of that node.
Continue.
Yeah, with, I mean, I'm coming back to hash set.
As it
Uh,
is, we don't want, right?
yeah. I mean,
See, what I'm trying to say here is we every point what we will do here, we will take this as a starting point. Okay. So for one, we will only go till the current point. So this is right now the starting point. This is only the ending point. So for this, we will see that from where we started, there we ended. The length is the same. That means, okay, self loop is not there. Okay. Then we go to two. We start from one only iterating. So we went to one and then two. We reached the ending point here. We will see that now the length is two. Again, we didn't found the self loop. Again, we will erase this. We have an ending point over at three. So one, two, and three, it will traverse. Like always, it will start from the ending point. Okay. So the length here, again, it will get it as three, no self loop. Now, again, it will move its, what I'll say, the ending point to four. When it will iterate from the starting point, again, it will get the length as four. Again, no self loop. Everyone, are you getting it? What we are doing? We have fixed our starting point as the starting node, and we are are continuously one by one moving our ending node to the like one node ahead. Is everyone able to follow this? Others in the class, are you guys able to follow this? So what I'm trying to say here is that our agenda is to find some brute force to this particular problem. Okay, no hat set, no extra space included. For that, what I'm trying to say here is that how can we find our intersection point? You fix your starting node at 1, and right now your current node is also 1, so keep it as your ending point. Okay, now you have to start iterating from your starting point and go till your ending point. Getting this? So when you will do this for your first node, you will see that you started and ended. Basically, we are calculating length for every iteration. So for this iteration, you will get the length as 1, right? That means there was only one node, you got the length as 1. That means there is no self loop, right? Are you getting this? Yeah. Now, here you will see that at 2, when you will go, your ending point will become now 2. You started from 1, you're traversing till 2. That means again, there is no self loop. Like whatever your number of nodes were, that much only you traversed. When you will go to 3 also, the same thing will happen. 4 also same thing will happen. 5 also same thing will happen. And same thing goes for every other node until 11. When it will again go to 5, okay, for 5 this time its length should be coming as 12 because it has already traversed 11 nodes. Now it should be getting as 12. Are you getting it? But what length it will be getting over here? Just a minute, guys. No, what I'm trying to say here is that, see, your ending point now, after rotating around this entire circle, this is your ending point. Okay, for this ending point, you should be getting the length equals to 12, correct? But when you will start traversing from the starting point, you will get your ending point at length equals to 5 only. And that is where you will know that there is a self loop in this particular linked list. Getting this? And this particular, you all can very well notice that starting point is fixed and every time you are traversing around the linked list, right? So you're traversing on the n nodes and every time you're traversing for n times. So for this, the time complexity will be n square and your space complexity will be 1. Are you getting this?
Ma'am, one thing I'm not clear.
Yeah, ask.
After I travel from 11 to 5,
Mhm.
how do I know that it's a loop? Like,
See, you traversed your first node, you will keep a track of your length. That is the one thing. So
correct,
when
correct.
you were at 1, you recorded your length as 1.
Yeah,
When you moved to second node, you recorded your length as 2.
correct.
Okay, and when you started traversing from starting point to ending point, you also got the length as 2. You matched them both and you got that, okay, the self loop doesn't exist. Getting it?
Yeah,
If
yeah.
you're not getting it, be clear, okay? What
No,
I'm
no, I'm
saying
clear until
is
11. Until
you
11,
are
I know.
maintaining length and you are maintaining main length and temporary length. Your main length here is 2. And when you start traversing from 1 to 2, again, you will get your temporary length as 2. Both are matching. That means self loop doesn't exist. Clear?
Yeah,
Same thing goes with up to 11.
yeah,
But when you will go to 5 now, 5 is your 12th node, right? Now, after
yeah,
11, it will be 12th. So your main
yeah,
length will be 12.
yeah,
when you will be traversing in your, like from starting point for your current node, you will traverse first node, you will traverse second node, third node, fourth node, and fifth node. At fifth, you know that you have reached your current node. Yes or no?
Okay, so we are maintaining two traversal technique. For main line, we are going until 12, and for another line, we are going until.
No, main iteration and temporary iteration. Main iteration is like one by one moving, okay?
Yeah.
And temporary iteration is every time moving from first till the ending, wherever your ending node lies. Getting it?
Temporary, I'm not clear. Like I just
See,
understood one way.
see, you are at 1, this
Yeah.
is 2, this is 3, 4, 5, and 6. Imagine this is your linked list.
Yeah. Yeah.
Yeah. What we are doing, this is your starting point right now. This is your ending point right now. How much traversal? 1.
One,
Next time, this is your starting point, this is your ending point.
two.
So this iteration happened, your ending point moved, right?
Yeah.
Next, you will traverse from starting to ending again.
I have one question here.
See,
Is it
start,
through?
wait, and
Yeah.
ending, start and ending, and start and ending here. Now, every time, imagine this is your E, initially is at 1, okay? So it is moving to 2, then 3, then 4, then 5. This is the main loop. Clear?
Yes. Yes.
Next thing what we are doing, every time we are iterating inside also. Clear?
So the first time we are just moving the pointer to next, and the second one is
We are
iterating from beginning till the end. I got it.
correct. So then this time you will be moving from starting to the ending. You will find your 5 in the middle, right? Like after 5 iterations, you will get it.
Yeah.
So now your temporary length will be 5, but your main length should be 12. Getting it?
Yeah.
And that's where it mismatch. I hope I made it clear to you, but if you have any doubt now, also you can ask.
So while we are iterating, we are also comparing the end with each of the iterating temporary loop. So
When we are iterating, we are iterating only up to E, wherever our ending pointer lies. And at the end, we just match our temporary length with the main length. If they are equal, that means loop doesn't exist. If, like, let's suppose it doesn't match, that means loop exists. That's it we have to do.
yeah, correct. So what I'm thinking is we are comparing the hash code of the endpoint with everything which is going in the temporary loop.
Yeah, right. Like every time we have to check that whether we have reached the ending point or not. So we have to.
Okay, yeah, it makes sense now.
Okay, like it's completely like a searching problem that you are searching for your ending point. As soon as you are getting your ending point, you are matching the length. Clear?
Yes.
Okay, great. So I hope you all got this particular what should I say, solution. Now we'll move on to the next. Here, it's an optimized solution what Kishan was referring to. We'll see that, Kishan. So here again, we will take our starting. I'll say slow and fast pointer. So in the first, I'll just keep on writing, okay, the values. So initially your slow is at 0. Your fast is at 0. Next time, where will they go? Can anyone help me with this? Quickly, we'll fill it up.
Fast will be at 2 and slow will be at 1.
It will be at 2. It will be at 1. Next. Be quick.
So slow will be 2 and then fast will be 4.
Just a minute. Okay, you guys are writing in the chat box. I was not able to see. Yeah. So your fast will be at 4 and your slow will be at 2.
Yeah.
Next.
Fast will be at 6. And
Slow.
will
We'll
be
first
2.
go with slow. Slow will be at 3. This will be at 6. This will be at 4. This will be at 8.
Yeah.
Now this will be at 5. Here this will be at
3.
3 again. Yeah. Now
And then again it will be at slow will be at 6
6.
and fast will be at 5.
Next, I'll write here.
Yeah. Then slow will be at 7.
Okay.
And fast will be at 7.
7. Yeah, right. 7 only. So both met, right?
Yeah.
So if they are in a loop, it is for sure that slow and fast are going to meet at some point. Are you getting this?
Yeah.
Now the question is why? Why are they meeting? Like, is it sure? Is it not a case that they keep continuing revolving around the loop and never ends? Like, isn't that a possibility? Are you all getting me? Like, you must be getting this doubt, right? Like, that we are traversing in a loop, so probably it should happen.
No,
Why?
because at some point these even will merge into, because one is incrementing by 1, there's no way it can skip the fast pointer.
Yeah, right. That's correct. Everyone else, are you able to follow what Vishnu just said? So it met at 7. We know that self loop exists over here. That is one thing. But we don't know still the intersection point, right? Do we know it? No, we don't. How to find that? First section is justified. What to do with the next section? Think of some ideas and tell me. Store in a map or set. And then what? See, again, it will become a map set question. I don't want extra space to be taken. Are you guys thinking of something?
Yeah, I'm just thinking how how to store in a temporary variable.
Okay, think. You guys are able to see the whiteboard, right?
Yes, yes.
Okay.
So what I'm thinking is, as we are doing a slow traversal, we are storing it in, I mean, a new array. I don't know how else to keep track of the path it is taking, the slow one.
Okay.
Somehow we have to maintain the history to know that it's a cycle. What the point of intersection.
We have got our slow pointer over here. Okay. And we have our head over here. Just start moving your head, make it as h equals to h dot next, and try to move your slow also. So when you will move your head will move from initially it is at 0, slow is at 7, head will move to 1, slow will move to 8, head will move to 2, and this will also move to 2. But right now it just collided. In other cases also, they though they don't collide also, but eventually once revolving around the cycle at least once, like at least it like right now it didn't went into the cycle at all, but it can go into the cycle also, revolve once, and then it will get the answer. Now, like, are you guys getting what I'm trying to say here? I've not explained the logic behind it. I'm just asking, are you getting it?
No, I see one problem
Yeah, same.
that, like, yeah, the problem is that had they not been moving sequentially, uh, it would have never met. Like, for example, if, for example, head has moved to 3 and then the short one is at 8,
Mm-hmm.
it will,
I'm getting.
yeah, it will take forever to meet. I
Sorry,
mean,
Vishnu, I'm not getting you.
so I'm thinking that if the head is moving one by one and there's a difference between the short and the head by 2, they will never meet. Making sense?
No, I'm not getting you.
Okay. So, like, as we are moving head from 0 to 1 to 2,
Mm-hmm.
and the short one is moving 7, 8, 2, if it is missing by 1 point,
Okay.
then there will always be a gap of 1 and they will not meet. Making sense? No. So
Wait.
if they're traversing and one is behind the other in a cycle, then
Mm-hmm.
they will not meet.
See, we'll just quickly see what I'm trying. Yeah, can you repeat it once again?
Yeah. So supposing in a while loop, we are moving the head and the short pointer, uh, but and there is a gap of 1 or 2 between the short pointer and the head, they will
They
never
will
meet
keep on moving, right? But
forever.
now see here, we take this length as M, okay? This just a minute, just a minute. Yeah, so M, is there any lag in the screen?
No, for me.
Okay. Others, can you tell me as well? Okay. So what I'm trying to say here is M, and consider up to where your slow was as K, and the entire loop that you're running into is N. So overall, the distance that your slow pointer is gonna move is M plus wherever K it has met, plus there are chances that it is gonna move n times in this circle. So I'll say that number of times is P into N. Are you getting this? Now, for the fast pointer, we know it is double times the slow pointer, right? Are you getting it? So let's suppose that our fast pointer, it is making P turns. So a fast pointer would have made Q turns. So M plus K will remain the same, but just imagine that before meeting, it has made Q turns. It's not compulsory that it is gonna make the same number of turns, right? So I'll just write here, I am putting the values. It will be 2 times of M plus K plus PM. So here you will get M plus K plus Qn is equals to 2M plus 2K plus 2Pn. So 1 M and K will be cancelled. So you will be getting it as Qn is equals to M plus K plus 2Pn. Are you getting it? Any conclusion anyone figured out so far that what I'm trying to explain here? Yes, everyone. I'm not able to see us. Trying to make the relation of length of two nodes. Yeah, here what I'm trying to make, I'm just getting the value of M here. M, I'll get it as N common Q minus 2P minus k. Hello everyone. So like what we are imagining here is that Q and like P, we are considering the values as 1 or 2, whatever. Q is like twice or thrice. You can like right now you just ignore this particular term. Okay. So here what we are doing, n minus k we are trying to do. And what we are trying to observe here is that imagine your k is equals to 1 as of now. Okay, so what you're trying to make the observation as that even if like let's suppose slow is here and your fast was here, like slow was just about to enter into the cycle and fast pointer has already covered a distance and is in here. So they are behind. So right now what is the distance between them? This has just covered the n. So it is at n minus 1 distance, yes or no? Are you getting it? Like, sorry, my bad, not here. Slow is at start of this loop cycle and fast is one move ahead of it. So in this condition, the total like difference between them is n minus 1. The next time it will move, the distance is going to be n minus 2. Next time it will move, it's going to be n minus 3. Are you getting it? Because slow will be moving like one by one. Yep. Ultimately, this difference is going to end. And at the end, approximately you're going to get it as 0. And that's the point where slow and fast pointer meets. And yeah, you can say that the cycle exists. Clear? Next thing which I was telling you is we will start from here, the head, and we will start from slow. So your head is, let's suppose, is right now at 0. Okay. And your slow is at distance like what we can imagine it as m plus k wherever they met, plus let's suppose the number of iterations was pn. Right? Oh, guys, I guess there is a lack from my end because like I'm not able to see your messages. Hello, are you able to hear my
Yeah, yeah, yeah,
voice?
yeah. I'm able to hear, and I'm also able to see your cursor.
Yep, but like I cannot see your messages. I don't know what's the problem.
Do,
Hello.
Ma'am, do you have two screens or two monitors?
No, only one.
Oh, uh, okay. And is it laptop or a desktop?
It's a laptop.
Oh, okay. No, I'm just seeing some settings by which this could be put side by side. Just seeing that. Actually, I have two screens, so I won't be able to find out what is the problem.
I can hear your voice as well, but I am not sure that why am I not able to see the screen and all, like see your messages.
Maybe it's in two, like it's hidden behind the other.
No, actually, that's why I stopped the screen sharing so that I can see the messages properly.
Okay. I'm just typing something. Now you're able to see something. I mean,
I can hear your keyboard voice, but I cannot see anything.
uh,
Not sure what's happening. Okay, fine. What we'll do, you all just go today and find out the reason to it, like why we'll start from the head and the slow pointer and they meet at one point. If you are able to get it, then good. It will be a research topic for today. Otherwise, I'll just tell you the reason tomorrow. Will it be fine?
one thing I'm still hang on this, that the head, oh, like are we sequentially moving in a while loop, and short is also in the same while loop, or are they in two different while loops?
In the same while loop, anyways, it's gonna be an infinite loop, right? So we need not worry about null and all.
Okay, yeah. So infinite loop I can quickly understand, because if there's a gap between head and the slow pointer, they will never meet. Okay.
Um, See, right now, what you are imagining is your scenario, right?
Yeah.
But according to the question, you don't know where specifically you're gonna get your slow pointer and where is, like, you're starting your head from the start, but where you are going to get your slow pointer. Okay, so from that specific position and starting from the head, there is a chance for them to meet. Right now, we are framing the scenarios in our head according to our own condition to make it fail, right?
Mhm. Correct.
But according to the question, we are getting the slow pointer at a place, like they are intersecting at that place from where, if you start your head pointer from the start and you take your slow pointer from where it is, they are definitely gonna meet. Are you clear?
Yeah.
So it's always like that. This question completely depends on, like, this removal part completely depends that how you are gonna get, where you are gonna get your slow pointer.
Yeah.
Getting it?
Right.
Yeah.
Mhm.
So that's the scene. And there are many other ways also you can do it, like slow. I'll just share the screen. There are many other ways you can also do it. This was the most optimized way I told you all. Okay. So can anyone other tell me, like, what other ways we can solve it? Like any way through which we can break it? Are you guys able to hear my voice?
Yeah, 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 yeah. I mean, the only way is to store it in a temp variable, the history of what path we are taking, like all the hash code. But that is not an option. Moving ahead will always change the size of the linked list, and we, even if we find somewhere they meet, we won't be able to pinpoint at what distance from the
See,
front
anyways,
link.
you know that you have a hash set solution already. So this
Correct.
question is done, but I'm trying to make this solution work in n comma 1 time complexity. That is time complexity as 1 and space complexity as 1. So for that only we are struggling right now to find out the solution. So today, even if you're not able to find the reason, just try to implement the slow faster technique. One thing. Next, try to make that make the link which is forming the self loop as null. Are you clear?
Self loop as null.
This like 8 is
Yeah.
pointing to 2, right? So you have to disconnect this link and point this 8 to null. Clear?
Oh, okay, got it.
Yeah. So
Yeah.
that thing you have to do. So try to do it today and I will discuss the reason tomorrow.
Okay.
Okay. Till then, I'll check what's the problem with my Zoom. So yes. Okay, all. Thank you for attending the session.
One more
We'll-
question.
Yeah.
Did you get chance to look into the intersection code which I sent?
No, Kishan, I have not seen it.
Not an
I'll
issue.
see it today and we'll get back to you tomorrow. So tomorrow we'll start our trees for sure. Like there's no escaping to that.
Sure. Okay.
Okay, yeah. So thank you all for attending the session today and
Yeah.
sorry for the glitch. Yeah, thank you.
That's fine. Thank you.